Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, welcome back class. How are you? Okay, today we start with selawat Nabi and good pray for study. Bismillahirrahmanirrahim. Allahumma salli ala Okay, well, next we continue our lecture about the engineering design, chapter 6. Okay, chapter 6 talk about the selecting manufacturing process. Okay, here this first subchapter for this topic about the manufacturing process decision, deformation process, and then casting process, sheet metal working, polymer processing, machining, finishing, assembly, and material compatibility, process compatibility, material cost, tooling cost, process cost. Okay, example here we have a mountain bike. How we manufacture a mountain bike? Here we have this body from steel. Okay, top tube, down tube. Okay, we have fork here, we have handle, the saddle, tire, okay, rim, rear derailleur, okay, pedal, so on. This example. What the material we use this to make the mountain bike. Here first, what we can choose the specific manufacturing process. Second one, how do the select material influence on the choice of the manufacturing process? Produce function of performance issue influence our choice of performance. What criteria should be used to select process? Which criteria are more important? Who will make the final decision? Okay, this the process we follow how to select the process manufacturer. Here example, part undergo sequence of the process. Actually, is material. Okay, we have a primary, we call it a raw material. The basic shape or form. Example, is a raw, sand casting, rolling, forging, and sheet metal. Okay. Second, we have secondary process. We add or remove geometry features from the basic form. We use the machining. Example for brake drums casting, drilling, punching, or of the radiator housing, trimming, and injection mold, flush. Okay, this we know the primary and the second. The three process as a example with surface treatment. Example, painting, polishing, heat treatment, joining. Okay, this the three. How we consider the part of manufacturing process? First, we must know about the production volume. How many part you want to produce in 1 year? Example, 1,500,000 and so on. Part size overall, how dimension, X, Y, Z, the size, height, length, and width. Okay, and then the shape capability features. Example, boss dimension 1D, 1 dimension. Boss division more than 1 dimension. Hole, we have undercut, uniform wall, cross section, rotation symmetry, and capture cavities. Okay, was this consider these three items. Next, we have for your information, we have many manufacturing process. How we input the material chain. From the raw material, we go to the binary process. We have deformation like extrusion, forging, rolling, and so on. Casting, sheet metal. Okay, this secondary process. Okay, polymer process, this blowing mold, and so on. Machining, finishing, and assembly. is about the manufacturing process. Example, here we have rolling, extrusion, drawing, and fogging. Okay, if your you can imagine this process. Actually, this name is you can imagine the process. Next is about the rolling. Rolling is example, we have a thick slab, thick slab, and then we rolling the slab here. We have two roller to compress the plastic deformation. This slab to the from the example here we have from the 10 mm thickness of the metal, and then we go to example 3 mm thin sheet. Okay. This example for the rolling from the ingot or slab. Okay, from ingot go to slab, slab go to sheet, sheet go to coil. Example here from the bloom go to structure to C channel of the I-beam. So we have a billet, it's called billet. From the billet going to bar or the rod. Distribution. Okay, but the process is the construction only we have two. The other is sphere or the square. Okay, this pulling process here, no ram. It's a pull. Okay, we have other process. We have fogging, closing die. Okay, you put the this die or die this block for preform, and then we press using the mold. Okay, you press mold. Okay, this and the metal we follow the shape. Example, you have sand casting, die casting, and casting. Example, sand casting you have already learned in the manufacturing process. Okay, we use the sand. Okay, sand to mold the product. Okay, you have go here riser. Okay, we pour the molten metal here, and then the molten metal we flow inside the mold. Okay, so die casting here we have a metal pusher and have plunger to push the material inside the mold. Okay, with die casting. And then we have investment casting. Investment casting, actually we have two process. First we to create the wax pattern, wax pattern, and then after we get the pattern, we combine with the pattern 3, the wax pattern 3, and then we hold the use the ceramic mold to harness the slurry, the outside one, and then we input the inside the sand mold. Okay, and then inside here we pour the sand, and we remove the we heat the temperature, and the wax will remove. Okay, after this area is removed. Okay, we pour the molten metal inside the casting. Okay, and then we remove the ceramic mold is removed. Okay, this is ceramic, we remove the ceramic. Okay, this other for process for manufacturing sheet metal working. Other secondary process, bending, blanking, drawing, punching, shearing, and spinning. What's called this punching? Okay, this example here. This our material. We put the blank holder here and we'll punch. Blank holder to hold the between the die, and then we punch to make sure that with the high force, and then the punch ram with here, and then we get this shape. Okay, this shape. Okay, the U shape, and then this punch line will be removed, and we get the blank holder also will remove, and you get the sheet metal. Polymer process, we have a compress molding, transfer molding, blowing molding, and injection molding. Okay, the example composition molding. Okay, this we have heated mold. This will be heated, and then this charge, this material will be we make we have the size of material charge. Okay, either this plastic or metal. We can use this method, and then we ram press to get this part. Okay, next we have a transfer mold. Transfer mold for this example here, meaning we have a ram, and if you have charge here, and then he heated mold, also uses heated mold, and we press, and then the material, we have a sprue here and this part separated. This we call it transfer, and then this sprue part we will remove, not use, only the part area we use. Blow mold. Okay, this is blow mold. The first step is automated precision is extrusion. Okay, from this the nozzle. Okay, you inject the material inside there here. Okay, material we like this one, and then we transfer in move the precision inside the mold here. Okay, this already this like sudah panas lah. So, and then we put inside the mold this the mold shape. Okay, and then we close the mold, and then you use the air to blow the precision, and then the material will be open here, and then going out, and then we after we complete the shape, and we open the mold, and you get the part. Injection molding. Injection mold is using the pellet with a material, and then the material will inside the feeder hopper, and with a barrel like a screw item. The move the material here. Here we have a heating to heat the material. Material will melt. Again, then we use the screw to push the material inside the mold. Okay, we have cavity. This fixed mold, and this movable mold. And this use injector to the last. Okay, we put here, we close the mold and inject the material and the hole a few second time, and then we open the mold, and injector will push the part will be going down. Okay, example for the box with no undercut. Okay, this straight part. Okay, the mold is straight. Okay, and then this we have two part. We have cavity part and with a core part. This inject the pin. Example, after we inject the injection mold, and we part with a stick with the core part, and then injection pin with the push the material, and then we get the part. Okay, this with an internal undercut. This undercut. After, even though we open the mold, okay, the part cannot be removed easily. Okay, we have a secondary injector to open. After open the mold, okay, we have another injector here to remove from the stick here. Okay, this is external injector. Okay, meaning when this condition, this core will remove first. Second, we have another injector pin to push out there. We cannot do it like this one lah, with external. Solidification process, automated material, phasing, and solid part. Okay, this we call this process solidification. we have a casting process. Under casting process, we sand casting, die casting, glass casting. Okay, this written and polymer process also. This under solidification process, and we have under okay this we will we call is a parameter to consider. Consider the when we use this process: flow, cooling time, temperature, mold complexity, web page, post processing, and cost. Okay, this machining process. We have boring, drilling, facing, grinding, and so on lah. Okay, machining. Can read this. Okay, we can imagine from the name. Okay, surface roughness. Okay, this surface roughness. Okay, we have process, the machining process, and the roughness. This is micro inchy. Okay, this when we use a turning, this quite big. Okay, 32, boring also 16 to 120. This micrometer, micro inchy, milling 32, drilling. Okay, this is very big. Reaming is 16 to 125, boring and filling. When you finishing process, this very small roughness, micro inch. Precision grinding is 2 until 16. Typing is 2 and 16. So for finishing 1 to 8. Okay, this you must know the process what you know the surface. Okay, this your item you must consider. Okay, the parameter when you need this process. You know the hardness, strength of the material, shear force, too big aware of need of replacement, size of workpiece, too big or small. Okay, volume, how many we call this removable material, rate of removal, HP needed. Okay, tolerance, operation skill, or use CNC, and lastly cost. The process is like analyzing, honing, painting, plating, and finishing. Next, assembly is automated, bonding, brazing, manual, rivet, okay, soldering, and welding. And if another is assembly is permanent or not. Okay. From the process of material screening, first when you do process first approach, we need you can see refer to the third slide. Okay, for the metal first approach, okay, first you must know the first apply load, magnitude, circle of nature, rate, duration, ambient condition, temperature, second ambient condition. Okay, how about temperature, how about moisture, sunlight. Okay, then third is chemical liquid paper. Number 3 is safety, legal, and lastly cost. Okay, this already into this I will explain from the previous lecture. Okay, this metric you can from the metal process capability. Okay, you can see. Okay, when the color is light is a normal practice. The grey color is less common, and the not applicable is the dark color. Okay, you can see sun casting with cast iron can use as a carbon steel, alloy, stainless steel, aluminium, and copper alloy. Okay, can you also this less common zinc and alloy using the sand casting. Aluminium can use as a sand casting, and so on lah. Okay, you can follow this, refer the chart. Okay, this we have process, solidification process, bulk deformation, metal removing, and profile generated require EDM, and sheet forming, sheet metal bending, thermoforming, and metal spinning. Okay, here this when this manufacturing process and product generation. Okay, this already from that this when you to process these 3 items: product volume, part size, and shape quality. Okay, so what is what called 1D. This is only one dimension, only our demonstration on only one side. More than 1D is from the top, example from this side and the right side. See, informal wall, so thickness, this is a very cross section. Okay, 1, 2, 3, 4 section, and then cross section is constant cross section only one side. So one side, but not consistent, not uniform lah. The size is various. Okay, also this part of and is various thickness of the wall. Okay, axis for rotation is a symmetry, like this toys, like this shaft. Okay, and regular cross section, like this regular pattern, like star is a hexagon, is a not regular, is a semi-sphere. Enclosed hollow, part rotation molded part. This example, if our part is draft free surface, draft surface is a straight part. Okay, no more angle or no angle or different size. Okay, this is straight. You can see this angle, but angle which need the already have a draft angle. The top one is small. Okay, the near to center is biggest. Okay, this is symmetry, left and right. Okay, okay, we skip some. Okay, for the METALWORKING, okay, this how we calculate the how we do calculation for manufacturing cost. Total manufacturing cost is material cost plus tooling cost plus tooling cost. Okay, material cost is raw material. Okay, tooling cost, example with mold, picture, jig, and tool bits. Okay, this tooling cost. Processing is like labor cost, electrical supply, overhead. Overhead is this deflation. Okay, total TMC, this formula M plus T plus P. Okay, material cost per part. Okay, how we calculate? Okay, metal M is total material cost. This pro verb. Q is quantity, production quantity. Then how we get the material cost? Material cost CM. M divided by Q is material cost divided by quantity. Example, our material cost is 1000. We have only produced 1000 unit. We get this the material cost per part is only RM1. Okay, how recognize the variable in the equation above? Of course, per weight over the part number, cost weight and weight per part. Before we get the cost per part. Material cost per part. Okay, this formula 6.2 material cost equal to weight, this W. Material cost per unit weight is cost weight is times of WP plus WW. Okay, weight of finished part plus weight of wasted part. Or finished part also we count is as a waste. So okay, it's mean scrap equal to cost material times W weight of part plus this alpha is ratio waste material weight and finished part, meanings WP and WP divided by WP. This rejected part. Okay, cost material equal CW WP plus 1 plus alpha. Okay, this is alpha is a ratio wasted material the finished part over the finished part. Meaning is rejected. Meaning example you have create 10 unit. Okay, during the you produce a 10 unit, two unit was reject. Also we need count as this alpha. 2 unit is okay. Example here, this cost material CM cost material cost 1 per pound times 1 pound per part plus 1 plus 0.5 means the total material cost is 1.05 per part. Okay, the tooling cost, how to do tooling cost? Cost tooling equal to total number of mole divided by quantity. Okay, we get the example, the tooling cost 10,000 per run is per run. Okay, then divide by quantity 5,000 part per run equal, we get the 2 ringgit per. And then process cost, CT cost per hour, this meaning machine rate plus the labor. T is a time cycle. Process cost is cost per hour time cycle. Okay. Example CP we get 30 ringgit per hour times 0.3 hour per part, and we get this 9 ringgit per part. Okay, total cost per part, this one. Okay, all this one. Okay, and then we have example here, sand casting, total cost per part 1.05 plus 2 ringgit. This is material cost, 2 ringgit is tooling cost, and this 9 ringgit is process cost. Meaning, okay, total is 12.05 per part. Okay, this is example, cost per 5,000 part per run. Okay, when this using this manufacturing process. Okay, example, example A, B, C. Okay, we have A using the sand casting aluminum alloy, and this part is 1 pound. This alpha 0.05. Okay, material cost $1, tooling cost 10,000, quantity 500,000, cycle time 0.3, machine rate $50, and total cost, part cost is 12.05. Okay, when you use the active injection mold ABS, this cost is $10.7575, and okay, use the alternative C machining for bronze alloy, the total cost is 47.1, because what this meter part per. Okay, this example. Example, when you do the sand casting A, this dot. Okay, less quantity. Okay, if less quantity we have higher price. Okay, B, injection mold, also less quantity, higher price. Okay, until to 6,000, very low, very cheap. And the last one, machining is less quantity, this a little bit worse, and then this continues. Okay, how we can lower the cost of part? Okay, purchase less expensive material, keep our finishing parts weight low, produce little manufacturing waste, design simple part that result in a less expensive tool, many part production run. SMT, we use a batch production. 6, choose a manufacturing process that has a low cycle time and cost per hour. Minimize the sum of the term. Okay, this is how we can lower. Okay, this is a summary for today. Manufacturing process, decision, deformation process, casting, sheet, metalworking, polymer processing, machining, finishing, and assembly, and lastly is material cost, tooling cost, and process cost. Okay guys, thank you for your attention. See you next time. Tangguh dengan tasbih kara dan suara nas. Thank you guys. Assalamualaikum warahmatullahi wabarakatuh.